Hello everyone, I'm Andrew Murphy, and I will be talking to you today about our work on the preparation of hydrogel-coated gold nanoshell biosensors for the detection of disease biomarkers. So the motivation behind our work has been the growing work in the field of proteomics, which has enabled the discovery of multiple protein biomarkers that have been associated with diseases, and the ability to detect these biomarkers can then be used to help with early detection of these diseases. One disease in particular we're interested in is Sjogren's syndrome, an autoimmune disease characterized by the loss of lacrimal salivary gland function. And some biomarkers have been identified that including lysozyme, lactoferrin, and lipocalin that we are interested in being able to detect in patient tears. How we are looking to do that is through the use of gold nanoshells. So gold nanoshells are particularly advantageous for sensing purposes because when they are bound to the target of interest, what happens is they will exhibit a shift in the localized surface plasmon resonance wavelength, and that can be related to the concentration of protein in solution. And so we are attempting to exploit gold nanoshells because they have a much stronger LSPR shift for the same amount of brown material compared to other LSPR active materials. However, there is a disadvantage in this approach in that the sensing is not tied directly to the protein of interest. It is activated by anything mass-wise that's bound to the surface. And so we are looking for ways to improve the sensitivity and targeting towards specific proteins. And how we're going to do that is through a hydrogel coating. How this coating is prepared is through an inverse emulsion polymerization, where we include the gold nanoshells in the aqueous phase along with the monomers of interest. We conduct the polymerization and then we purify the resulting products, and then wash the gold nanoshells to remove any unbound polymer, and then we're left with a hydrogel coating on the surface of the gold nanoshells that can be tailored towards a specific binding by changing the monomers that we include to, be targeted towards specific functional aspects of the protein, such as certain amino acids. From our results, we then characterize the properties of the gold nanoshells and hydrogels. So speaking first about the nanogels that do not have nanoshells in them, we characterize these by dynamic light scattering, potentiometric titration methods in order to look at the content of these particles. And we found for several different formulations we did at both different reaction volumes as well as different compositions that the formulations were comparable for most cases, with the NIPAM particles being slightly larger and a comparable surface zeta potential for all formulations. Additionally, when we were looking at the particles prepared with nanoshells in the solution, we looked at the composition as well as the hydrogel coating through dynamic light scattering, transmission electron microscopy, and UV vis spectroscopy. And just showcasing some of the data here, you could see the DLS results, where you see the size increase for both formulations, confirming that we were able to incorporate incorporate polymer on the surface, as well as the change in surface zeta potential due to the mass of the polymer on the surface, providing some degree of shielding. And you'll see that we were able to maintain monodispersed particles with a PDI of below 0.2 in all cases. And you did see that the NIPAM formulation had a much larger increase in size than the acrylamide formulation under these conditions. And so, as a result, we feel that this is a promising strategy for preparing hydrogel coatings on the surface of gold nanoshells that can be used as a protein biosensor, and we are looking at enabling many more monomers that could be used to specifically target, such as reversible covalent, or various other groups that can be targeted towards specific amino acids that will enable us to improve our approach and target this towards specific proteins. Thank you.